12, slope-intercept form. This is one of the most popular equations in all of algebra. Y equals mx plus b. So let's get started. We've got a couple of learning objectives here. First, we're going to learn how to read y equals mx plus b. Next, we'll use slope and the y-intercept to write the equation of a line, which, foreshadowing, looks like that. And then we'll create a table, XY table, and we'll use the formula to complete the table or the equation. So let's just get started by looking at the equation y equals m times mx plus b. It's used to represent a linear function, which we know from a previous lesson is just a straight line when you graph it. Remember that? Straight line. That's our linear function. And it's just a clear, concise way to describe the relationships or the, it's just the relationship between the values. M here, that's your slope. So that's your rise over your run. That tells us how steep the line is. Remember steepness? Slope is steepness. So that M is the steepness of the line. And your B, well, that's where it crosses the y-axis. So some things you must know is a relation. To get a relation is just an ordered pair, right? X, Y. You need to know slope, which is the steepness of a line. And remember, there's four kinds of slope, all right? There's increasing, decreasing, constant, or undefined. Well, you'll need to know that. You'll need to know the y-intercept, which is your B. That's where it crosses, your line crosses the y-axis. And you need to know how to use tables. And I know you can do all this stuff because we've already done it. So slope, just once again, slope is just how steep a line is. It can be, whether it's going up or down, it's the steepness. We have it here, it's increasing. Remember, increasing slope's a positive number, decreasing is negative, constant is 0, and undefined is undefined, and it's y over x. Y is your y-axis, x is your x-axis, y, x. So let's just look at parts of a linear equation. So you got here, that's your b. Just a reminder, that's your b. Here, we're going to draw this little red triangle, use these 2 points here. Well, that's 3 over 3. So that's 3 over 3 or 1. We look at the line. We draw our stick figure. They're walking down. So the slope of this line is -1. So you got -1x, and your y-intercept is 3. And that's really, in a nutshell, how you write the equation of a line given a graph. So we'll be using our y-intercept, the steepness or slope of a line, and we'll be calculating slope. So just to recap from the previous one, we have y equals -1x plus 3. I think that's what we got. And let's look at some more examples. But once again, it's all y equals mx plus b. We can use this equation to find any point on a line. Tables are good, right? Don't get me wrong, I like tables. But the drawback to a table is you're limited by your space on the table. So here, like with this table, we have 0 through 4. But what if we wanted to know what, say, like 71 was? Well, you would just plug in this case, y is equal to -1 times 71 plus 3, which would be -71 plus 3, 71 minus 3, well, that's See, 71 minus 1 is 70, 70 minus 2, so it would be negative 68. So we can use this, using this equation, we're able to find any point, even if it's not on the table or the graph. So that's one important part here. So we got some examples. And what we're going to do is we're going to graph this. So a moment ago, we used the equation to write a quick equation of a line. So now we're going to graph it. So we're going to put it on our XY plane. And here's a little bit better grid. So to graph it, you find 2 on your y-axis. So here's 0, 1, 2. And then your slope tells you how far up or down to go. I'm going to go up 1, then I'm going to go over 2. And I went down 1 over 2 because my slope is positive. So we got a slope is positive, and I want to point out something here. It's a good time to pay attention, which means the line increases. And this is important to know when we're plotting our points. So I started here and I went up 1. I went to the right 2 because I know my line needs to go up. And when I went down 1, I went over 2 once again because I know I wanted my line to go up. So go ahead and pause the video and see what you can come up with for this graph. So your graph should look like this. And when you draw your stick figure on it, your stick figure is walking uphill. So once again, 2 tells us where to start. Our slope tells us that our line should be slanted upward. So when I put my first on at 2, if I went down 1 over 2, I still want to place my dot to the left because that's going to make my line go up. If you went down over right 2, see your line's going down, and that's just not correct. That would be a negative slope. So you always want to pay attention to the slope. Pay attention. I'm going to write it down because it's important. Pay attention to the slope. Because your slope's going to tell you which way to point that line. So now let's look at a table. So we can use this to create values in a table. What I like to do is pick 0. So you want to put 0 in the middle of our table, and these tables are designed so that you can easily put a 0 here. And then you want to put x values that are multiples of the denominator. So we got 2 here. So 2 is obviously a multiple of 2. So I would count by 2s. You got 2, 4. And then we're going to want these to be negative because they're below 0. And then we want positive 2 and 4. And if you're graphing, we'll pick the numbers you can see on the number lines. And you see these numbers here? They're all on the number line, right? Like all the number lines we've been using, we've got these x values. Now we got to figure out what the y values are. So to figure out what the y values are, you just plug it in for x. You have y is equal to 1/2 times negative 4 plus 2. Well, what's 1/2 of negative 4? That's right, that's negative 2. Negative 2 plus 2 is 0, so you put a 0 here. And then we're going to do our next x value, which is negative 2. Y is equal to 1/2 times negative 2 plus 2. Well, what's half of negative 2? Well, that's right, that's negative 1 plus 1 is equal to, plus 2, give away the answer. Negative 1/2 plus 2 is 1, so we have a 1 here. We'll do y is equal to 1/2 times 0. We're getting 0 from the table, plus 2 from our equation. Well, what's any number times 0? That's right, that's 0. So y is equal to 2. I want to let you try to figure out these last two on your own, but don't worry. On the next slide, I'll give you the answers and work through those last two with you. So, well, I've got 3 and 4 for my next two answers. It's just work them together and make sure nobody's lost. Using this equation in this table, we're always going to use this equation because it's what's given to us. You do 1/2 times this x value, because that's in the table, times 2 plus 2. Well, half of 2 is 1. 1 plus 2 is 3, which that checks out. Next, do y is equal to 1/2 times 4 plus 2. So half of 4 is 2. 2 plus 2 is 4. So your table should look like this. You got your x inputs, and we made those up. I gave you a rule of thumb, and I always like to use multiples, and I like to start with the smallest multiples, 0 in the middle, and then these two numbers, I like for them to be opposite of these two numbers, because when you graph, it's just going to make it easier. Okay, now it's time to analyze the table. A lot of times, especially on standardized tests, you're going to be asked these kind of questions. So let's talk about them. And remember, we're working on y is equal to mx plus b. Sometimes I will write it as y is equal to rise, which is y, over run, which is x, plus b. So what do we notice about the x values? Go ahead and draw these little triangles here. What do you notice? Well, I notice they go up by 2 each time. So if you look at our original equation, and the run spot is 2. So remember, this first column is your run, which means your second column must be your rise. So now what do we notice about the rise? Probably figure that out already because you're smart people. It increases by 1. So every time, so how does that compare to the x coefficient? Every time y increases, so every time y increases by 1, x increases by 2. So every time y increases by 1, x increases by 2. And that's how you would answer those questions. You just verbally describe what's happening. So now let's see if we can graph this on the next slide. A couple of slides ago, but just to recap, to graph this, you start at 2. You use your slope to go up 1 over 2. Up 1 over 2. And we drew this line with the positive slope because it's a positive slope, right? I want to sound curved, but that's it. It's a positive slope. A common question is, what do you notice about the graph in the table? Well, let's see what we notice here. So we already figured out x goes up by 2, y goes up by 1. Remember that from a minute ago. But let's look at this right here. So let's go to where x is -4. Well, where x is -4, y is 0, just like in the table. Well, let's go to where x is -2. Here's -2. Well, x is 1. We go to where x is 0. Well, that's 2. We go to where, let's go over here where it's cleaner. X is 4. We go up to 4. If we wanted to add 6 to the table, what do you think 6, if we make x is equal to 6, what do you think y is going to be? Well, you could follow the pattern here in the table and come up with 5. Or we could go to the graph, go to where x is 6, we'll go up, and we see that y is, over here is 5. If we went to 9, well, 9's not right on it, but 10 would be. So if we went to 10, you know 10 7's on it. If we wanted something, say, like 20, we could use the equation y is equal to 1/2 times 20 plus 2. What's half of 20? That's right, 10. 10 plus 2 is 12. So we do know x is 20, y is 12. That would be on the graph if we drew it out far enough, or if we took the table out far enough. So, building on what we did in the last slide, can you name 4 numbers not on the graph? And remember, we'll redo y equals 1/2 times 20 plus 2. Remember, we said x is equal to 20. That's clearly not on the graph. It's not on the table. But once again, half of 20 is 10. 10 plus 2 is 12. So when x is 20, y is 12. What I would do is look at your 2. Pick easy multiples of 2. Now here's where students kind of struggle, is sometimes they have a hard time picking out their own numbers. So if you have a hard time picking out your own numbers, why don't you pick out 30, 40, 50, and 60. You don't have to use 30, 40, 50, or 60, but when we come back in a minute, that's the numbers I'm going to use. All right, let's see what you got. And once again, I'm going to use 30, 40, 50, 60. So 1/2 of 30 times 2. Well, half of 30 is 15. 15 plus 2 is 17. So I know 30, 17 is on the graph. So now we'll do 40. So you got 1/2 of 40 plus 2. Well, what's half of 40? Well, that's 20. 20 plus 2 is 22. So we got 40, 22. Let's do 50. Well, what's half of 50? That's right. Half of 50 is 25. What's 25 plus 2? It's 27. You guys are doing good. So we have 50, 27. And then finally, 60. What's half of 60? 30. That's right. 30 plus 2 is 32. So now that's a 32. So now we got 60 plus 32. The reason I picked, multiples of 10, because it's easy to figure out what's half of 30, 40, 50, or 60. You might have picked 40, 60, 80, or 100. Whenever you're asked to name or pick, make your work easy. Pick easy numbers. There's nothing wrong with that. Makes your life way better. So let's look at example 2. And this right here is what's called the parent function. And it's probably something you want to commit to memory. It's called the parent function because all the other variations we pick come from this number. So we're going to complete the table, and you pick your own numbers, but I always like to do 0. And I'm going to write this out as 1/1x plus 0. Well, I need multiples of 1. So -1 is a multiple of 1, and -2 is a multiple of 1. Now I want to pick the opposites for down here, 1 and 2. And you're going to complete your y's. So you got y is equal to x. So when you do y equals x and you make x -2, there's no calculations. See if you can't figure this out on your own. And I'll have the answer for you on the next slide. Pause the video if you need to. So this is what your table should look like. This is the parent function. Next, we're going to graph this. So we're graphing. Remember, we're using the form y equals mx plus b. M's rise over run, and b's your y-intercept. It's intercept. So I'm going to, if you wanted to rewrite this as y equals 1 over 1 x plus 0, it's the same equation. The reason that we usually see it as y equals x is if we don't see a coefficient, it's understood to be 1. And we never write plus 0 because 0 added to anything is just itself. But learning this new stuff, I like to write it out because it helps you see that mathematics is really about patterns. So to graph using the equation, I start at 0. I look at my slope. My slope is positive slope. So I know my line is going to slant upwards. So I'll go up 1 and I go over 1. If I wanted to use my table, I would go to -1, -1. If I already got 0, I went 1, 1. I want to use the table to go to 2, 2. So there's different ways to graph. If you use the equation, you'll get the same graph. If you use your table, once again, you'll get the same graph. Now we connect the dots. And when we're done, you'll have a clean looking graph that looks just like this one here. I drew totally by hand, right? So once again, your table and your equation and your graph are just 3 different ways of expressing the same information. And we need these multiple representations because in the real world, a lot of times we're working with lots of different stuff. So it's good to have lots of different kind of tools. So looking at our parent function, what do you think will happen to the table and the graph if we added 1? So our equation right now is y is equal to x. And to be more precise, our equation is really y is equal to 1 over 1x plus 0. So what's going to happen if we rewrite it as 1 over 1x plus 1? What is this 1? Is this 1 is it the slope? Or is it your y-intercept? So think about it. Maybe pause the video, and then the next slide will carry us on. Well, let's just work the math here. If we're going to complete the table, I'm going to start with 0. -1 is a multiple of 1. -2 is a multiple of 2. And then I'm going to write the opposites, 1 and 2. So let's see here. We've got -2 plus 1, which is -1. That goes in our first one. -1 plus 1 is 0. 0 plus 1 is 1. 1 plus 1 is 2. 2 plus 1 is 3. Clean this up just so it's easier for you to look at. And this is something teachers don't really tell students to do. But with an equation like this, there's nothing wrong with writing that plus 1 in your boxes. Some people find that's easier to work with. If you find that easier to work with, do it. But now we've got our new outputs, our new y's. You may want to go back and look, but long story short, these are all 1 more because we added 1 to it. So now it's just in a cleaner format. Next, let's graph it. But before you graph it, you may want to just pause the video to think about what that graph might look like. So to graph, you can do 2 things. You can use your equation, go to plus 1, think about your slope. It's a plus, it's a positive slope, so it's going to go up. So I'll go up 1 over 1. Or I could look at my points on my graph. So I got 2, 3, right? It's 2, 3. I could also use these points. I can go to where x is -2, y is 1. But you see, all of these points on the table, they're all on the graph. Which is why our graph looks like this. And if you remember, the parent function would have been parallel to it. It would have been just a little bit below. See if I can. If it was +2, what do you think it would look like? Right, the same thing, except it would go through 2, and if it was +4, same thing, on and on forever, right? Because since it has the same slope, these lines are always going to be parallel, but the y-intercepts would be different. If for fun, you might want to go back and practice this on your own and just add different intercepts. You can even do negative, right? If it was x -4, it would still have the same slope. And just go through -4. So move on to example 4. This one, we got a negative slope. So just think about if we have a negative slope, do you think our numbers are going to increase or decrease? Just think about it, mentally think about it. And once again, I'm going to start with 0. I'm going to start with 5 because we want multiples of 5. So I'm going to do -5, -10. And then, really, instead of saying multiples, which is the correct math term, math teacher talk, probably what's better to say is just start with the bottom number, because I think that's easier for people to grasp. So we're going to start with 5, 10. So we just use that bottom number. Now we got our table ready to go. We used our bottom number as our starting number. We started with 0. 5, 10. Got the 5 from here to here. And we just did multiples. So to find our y values, we're just going to plug number. We're just going to plug it in. -3/5, that's our slope, times your x, which is -10 over 1. When I multiply fractions, I always like to write all my numbers as fractions. Some teachers don't do that. Some people don't do that, but I'm not very smart, and I have to do things the same way each time to make sure I get it right. A negative times a negative is a positive. So I'm going to just make that positive sign here so I don't forget it. 3 times 10 is 30. 5 times 1 is 5. 30 divided by 5 is 6. 6 minus 3 gives us 3 for our y1. We're going to look for y2, so we're going to take our slope, and then we're going to multiply by our next x value, which is -5. Negative times a negative is a positive, so I don't have to worry about my signs anymore. 3 times 5 is 15. 5 times 1 is 5. 15 divided by 5 is 3. 3 minus 3 is 0. You should be able to fill out the rest of this table on your own. Give you a minute to work on that, and I'll wait for you on the next slide. So here's what your table should look like. If you notice on your x, our tables, from -10 to 5, that's a +5, right? Over here is a +5. So our x's each time are going up by 5. And what do we notice about the y's? They're going down each time by 3. Remember from a couple of lessons ago what we called this? Oh, that's right. I'm glad you remember. It's a constant rate of change. And we have it on our x's and our y's. Sometimes people notice, oh, wait a minute, do I really need to plug this x in? Or can I just look at the slope? Because if I notice here, your equation is y over x, right? So if this is -3, these numbers should always be going down by -3. So if you have 3 and you know your slope is -3, that one's going to be 0. And then somebody else may notice, wait a minute, that 5, that's a +5. So if I start at -10, I should go +5. And you could do that if you see it. And see, that's the thing about math is once you start making these connections, it really does simplify your work. It makes things a lot easier. So now let's graph it. And I always like to graph with the equation. So that's what I'm going to do. If you want, you can graph with the table. I know it's negative, so I'm going to make this notation that my line needs to go down. So I'll start here at -3 and I go up. See, rise over run. I'm going to go ahead and write that out. So I'm going to rise 3 and run 5. So if I go down 3, 1, 2, 3, over 5 to the left, 1, 2, 3, 4, 5. That's the wrong way. 1, 2, 3, 4, 5. Now I put my dot, and I notice when I put the dot this way, the line's going down. And I went up 3, 1, 2, 3, over 5. It still would have went up. So I always like using the table. I mean the equation. To me, the equation is easier to solve. And here's a cleaner version because you start at 3. If you go up 1, 2, 3, put you on the x-axis. So go over 1, 2, 3, 4, 5. You're on it. If you went down 3, 1, 2, 3, over 5, you're still on it. A couple of common questions. So what's the slope of a line? Or you may see a question like the slope of a line. It's 4 over 7. So how much does the y increase for the slope of 4? What this means is, so pretend like you're walking. You take 1, 2, 3, 4, 5, 6, 7 steps to the right. You'll take 1, 2, 3, 4 steps up. So you're kind of going uphill. So that's one way to think about it. For every 7 steps you take to the right, you're going to go up 4. It's like walking uphill. So the line's going up at a steady pace. Another common question you may see is, if the run doubles, what's the new rise? So how I would approach that is I would write rise. I'd spell it right first. Rise 4, run 7. Double just means 2, so it could ask you triple or quadruple. So double means 2. So if I multiply 7 times 2, what do I need to multiply 4 by? That's right, 2. So it would be 8 over 14, which once again would reduce back to 4 over 7. But those are a couple of common questions. Another common question has to do with the parent function, y equals x. And I think it's just math anxiety, really. But what I would do, just write it out, right? Y equals mx plus b, and even the understood stuff like your one coefficient, I would write it. Even adding 0, I would write it. So what's the slope? Well, your slope is just 1 over 1 or 1. your y-intercept is 0. And that's just something that you almost got to commit to memory. But the slope is 1, the y-intercept is 0, and the line goes through the origin of your grid. So to recap, and you should have enough now to get your work done, but to recap, y is your dependent variable, x is your independent variable, the input, m is your slope. It tells you how steep the line is and whether it goes up or down. B is your y-intercept, or where your graph crosses the y-axis. And by using the slope-intercept form, you can find any point on the line, even if it's not on the visible graph or your table. You can also use it to complete a table. You can also use a table to write the equation of a line. You can use the table to graph. You can use y equals mx plus b to graph, and it's really an efficient way to graph. Just remember, it's a powerful tool to understanding and working with linear functions. There's 2 other forms of a linear line that we're going to work with, and once we work with those 2, we'll learn how to go back and forth, because depending on your situation, one form may be better than another. As always, if you have questions or need help, let me know.